All right, so we ended the last video just finishing out the synthetic division process, knowing that the root that we plugged in, obviously this being a root, x equals -2, that's one of our roots. We synthetically divided it out. We knew it was a root, so the factor or the remainder was going to come out to be 0. And then that yields a new polynomial function that is 1 degree less than where we started. So now we're down to a third degree. We're working down the pathway. Fourth degree, down to a third degree. If we can pull out another root synthetically, we'd be down to a second degree. And then that second degree, we can use quadratic formula or other factoring methods perhaps to then solve it out. So knowing from our calculator, right, if I pull this back up, all right, if you remember, we saw another root right here at x equals 2. So we used the x equals -2 the first time. We know that's a root because y came out to be 0. But we also have a second rational root here at +2. So if we synthetically divide that out, let's write that one out. We're going to put a +2. So again, this is because x equals 2. That's a root that we know from the graph. And we're going to copy the coefficients down. 1, -8, 19, -14. And we're going to synthetically divide this out a second time. We add straight down, that's 1. Multiply diagonally is 2. Add straight down, that's -6. And multiply diagonally, that's -12. Add straight down, that's 7. Multiply diagonally, that's going to be 14. And like we expected, this should come out to be a remainder of 0 because this is a root. So since it's factorable, the remainder should be 0. What this yields now for us is 3 new coefficients, but we went from a fourth degree, pulled out a root, got a third degree. Went from a third degree, pulled out a root, down to a second degree. So this is 1x squared minus 6x plus 7. So we're going to take that function and set it equal to 0. And this is where we can now finish up algebraically. So can this factor out? Well, we're not really sure. We're going to try it out. Can it multiply to +7 and add up to -6? You might be thinking of like -7 and +1. That would be great to add up to this, but it doesn't multiply to this. So if you look at this, it's actually going to be a little bit problematic. We're going to have to probably use the quadratic formula from this point on. So A is 1, B is -6, and C is going to be 7. So when we set up the quadratic formula, x is equal to -b, so that's going to be 6 plus or minus. Big square root symbol, we'll use the calculator in a second, all over 2 times A. So when we write this out, we need to figure out what this number is going to be in here. So I'm going to put the calculator back up. All right, I'm going to put it right down below here. And we're going to calculate what that discriminant value should be. So again, it's b squared. So that's -6 quantity squared. Make sure you put that in parentheses. It's not the same without the parentheses, remember. -4 times a times c, which is 7. And so what do we get as a result? We get the number 8. So our discriminant value is going to be a +8. So that's irrational because the square root of 8 is not a rational number. So when we write this out, that's a good thing that we didn't waste time trying to factor because that doesn't factor. That'll only factor if that discriminant is a perfect square. So when we write out our 2 answers, we basically get a t-chart out of this. All right, this represents 2 solutions on our answer key. And this would be 6 plus rad 8 over 2, and also 6 minus rad 8 over 2. So if we break down rad 8, depends on the directions. If it says write in simplest radical form, this would be 6 plus 2 rad 2 over 2. This would be 6 minus 2 rad 2 over 2. And so therefore 6 divided by 2 is 3, and 2 divided by 2 is 1, so 3 plus rad 2. And on the other side, it would be the conjugate, 3 minus rad 2. Complex numbers and irrational pairs, roots, they always come in conjugate pairs. So basically, we got 2 irrational roots out of this, and then we got 2 rational roots out of this. So if we wrote down the entire solution at the end of the road, all right, and we write out all our solutions, x is equal to -2, +2, it's also equal to 3 plus or minus rad 2. That would be the solution set for this particular unfactorable polynomial. Even though at the beginning it was unfactorable, we were able to use the 2 rational roots to reduce the degree and then turn it into something at the bottom that was finally solvable as a second degree. And that's generally going to be the premise for each of these problems.